Okay, welcome everybody to this week's data wrangling task. We've got a few London Airbnb listings for you this week. And what we are going to do is solve these tasks here, the ones in the PDF file that we've sent into the chat. You will also find this PDF on our website under the resources tab. And we are slowly going to walk through the exercises, and I'm going to explain some more details than the solutions. The first thing we want to do is create a folder somewhere on your computer. I've created a folder here on the documents and just named it our user group task. And then I've put the PDF in here. And how you're going to get this listings file, you can click on this link and it's going to bring you to a website with the raw data. And you can see that here. Just click or press Control-S for save or Command-S on Mac, I believe, and save it in the same folder as the PDF file. And you can see that here now. And you can already open that in Excel if you want to see it. You don't have to do that, but it should look something like this. The second thing you have to do is create a file in RStudio in which we're going to work. And in this case, I'm going to use a markdown file so I can add some text around code chunks. And you can do this here, new file, markdown, and you can name it whatever you want. You could name it our user group task and keep the HTML. We could knit it, but we're not going to show that this time. Just a quick note, I have my console to the right here, so I can use more of the screen, but visibly easier on your mobile phone or tablet. Your console will be down here where I have my environment now. So you can delete all of this. It's just an example of what you could do with Markdown. Actually, you can also delete this and just keep the title and the date. And the next thing you want to do is go here and save it, Control-S or Command-S on Mac, and save it in the same folder as the CSV file. You can also name it our user group task, and make sure to use the file extension RMD like this. Okay. So now we're going to do one more thing and go to session and set working directory to source file location like this. And you can see what it did is set our working directory to the folder that our CSV file is in, and that will make it easier for us to load the data. So let's see what the task says. We have a couple of packages that we have to load for the session. So let's start by doing this. You want to insert a code chunk. You can click on this C up here and then insert an R code chunk, or alternatively use the shortcut Control, Alt, and I. And this will make it faster to insert chunks. And I recommend learning this little shortcut. It'll help a lot. So in this chunk, we can code, and outside of this chunk, we can write text. We can also format text. For example, if we want to do a header, we can use a hashtag and say this is a header. And once we knit this file, this command, it'll output an HTML file that we can actually watch or host as a website even. But today we're just going to code in here, so you don't need to learn any of this. Just know that you have to write your code in these chunks. And you can see it already proposes me a couple of packages to load, but what I want here is the tidyverse package. And you can see there's some output below this chunk, and I don't want this. I want the output only in the console. So I'm going to go to this little cogwheel and click chunk output in console, and then say to remove all output. And like this, if we run the chunk now, it'll just write everything in the console and not under this chunk. So we've loaded this package now, and we're also going to load the library, the tidy models one. That's for machine learning models. And lastly, the tidy text, which is good for sorting bar plots in ggplot. And we can load all of them at once by pressing this little arrow to run the chunk, or alternatively pressing Control, Alt, and C. That's Control, Alt, and C on Windows. On Mac, it might be Command, Alt, and C. I'm not quite sure. So let's say loading our packages. So that's what we've done. And you can see in the output here, we've done that. That's wonderful. All done for the package loading. We've got the tidyverse commands now. So next, let's see what it says. We read in the CSV, which is in the same folder. You can see it here. It lies in the same folder as the RMD file. So we're going to go in here and we're going to insert another chunk and maybe name it listings. And we're going to do this assignment arrow to say whatever comes to the right should be stored in the listings variable. You can name this whatever you want. You could also name it data or listings, data frame, something like this. I'm just going to name it listings. And I'm going to use the read underscore CSV method or function. And you can see it proposes all of the files in the folder. And we're just going to use the listings.csv. And when we run this, we can see that we get a little bit of information. We can see 4 character columns, 11 double, so numeric columns, 1 logical, and 1 date. So we can safely say now that we have read in the file. Read the file. So now that we have our data read in, we can continue with the tasks. Let's see what the first task says. In the tidyverse, there are multiple functions that allow you to gain a quick overview over the data that you are working with. Try out the function glimpse to get all of the information in one step. So let's see how we can get the overview of a file with glimpse. Glimpse, and then we can pass a data frame or an object to glimpse as. That's what it says here. And let's pass in our data frame. And we can see it outputs all of this. And we have 83,000 listings and 17 columns. I have an index column, for example, the name of the listing. It says Holiday London double bedroom. Let's ongoing. I don't know what that means, but we have the host ID as well, the name of the host, neighborhood, latitude and longitude, room type, price, minimum nights, number of reviews, and all of this good stuff that we can use to analyze this data and plot it as well. So we can already say we have done task 1A. Let's proceed to B and insert a code chunk. So we can write our code in here and everything else, annotations, goes outside. B is check for missing and duplicated values. So we're going to start with missing values. And there's a neat little function that you can use. It's called isNA, and it checks for anything that is an NA value. NA values are just missing values that do not exist. There's nothing there. It isn't 0. It is just nothing. It's not available. You can imagine it is an empty cell in a data in an Excel spreadsheet. That would be an NA value in R terms or in programming terms. We can check with isNA, and we're going to pass our listings, and we can see what it outputs. We have 17 columns again, and the column names as well. And for each cell, it gives us a true or false. And we check for isNA. That means, is it an A? False means it is not an NA value. And anything that is true is an NA value. And we can wrap this inside of the column means function. And this will give us the fraction of NA values in each column. So this is 100% empty values. The neighborhood group is completely empty. That is a column that has almost no values. So not almost no values, absolutely no values. And this one has 25% no values. And we can use the pipe of the tidyverse. That means pass this here, pass it to the next function, and we can use the endFrame function. And it's going to just neatly give us the tibble back where we can have 2 columns, one as the column name of the data frame, and the value is the fraction of missing values. And then we can pass it on and say we want to sort this by the value column. And you can either use a minus with numeric values or a descending on the column name value. And you can see now we have it sorted from top to bottom. There are two columns where one quarter is missing and one where everything is missing, and then one or two where it's virtually complete. So that's our missing values. That's already it. You can use this code chunk on all data frames, and it's quite useful. If you wanted to count the number of missing values, so actual counts, you could use the same function here, this same bit, and just change the column means to column sums. And then you can see the actual counts. And as we have 83,850 rows, and the same numbers missing here, we have 100% missing values. Okay, now let's check for duplicates. Let's check duplicate rows. And you can use this little trick. You can take our data frame here, or our table that we have read in, and you can see all of the columns here, the column types, and all of the values, and then here the columns that can't be shown because the window is not wide enough. And we can pass it on to a function that's called dim, and it's going to give you back the dimensions. And you can see it has 83,000 rows, as we can see here, and 17 columns. So if we do the same thing now, take our data frame and pass it to distinct, it's going to drop all duplicate rows. And if we check the dimensions again, we see that we have the same dimensions on both. That means nothing was dropped, no rows were dropped. That means there were no duplicate values. So our conclusion is no duplicate values, no duplicates. Okay, and that is it for task 1B. Now we're going to count all nominal values and print the summary information on all numerical values. And for this, if you have no idea, you can scroll down and see if there is a solution for this one. Task 1C. Sorry, one sec. Okay. And you can see we have a chart, but no code. There should have actually been some code in here, but we're just going to show it in the video now. So we've counted all the nominal variables. That means for the variable neighborhood, we've counted all of the values in there. And there's one count function, or the count function that you can use, and you can pass in one column name. So I'm going to take the data frame and pass it on to the count function. And we want to look at the ones that are nominal, so not numeric ones. And let's first see which ones are actually nominal. We're going to do listings and select. And with select, you can select columns by their name. And you can also do select where is character. There we go. Oh. Is numeric. Does that work? Nope. One sec. Okay, we're going to keep this in here to see, to show you that even if you have already done this, it's quite a struggle every time you forget a little detail. For example, these two brackets shouldn't have been there. So we can select new character columns or nominal columns by using select where is character. And that's just a command that's really useful and equally transferable to other programming languages as well. For example, Python, pandas, there are similar commands to this. So it's just useful to learn these. They're going to help you down the line. And we can see it outputted a table with all the character values that we have in the data set. So the ones we are interested in are the ones with categories that are recurring or reoccurring a couple of times, and not only individual ones. So you call this a high cardinality column because every value is pretty much different. You don't have categories, for example, like cat or dog, that just repeats a lot of times. Same here for the names. Probably not that interesting to count these, and the ones that we want to look at are neighborhood and room type. So we can delete this and select neighborhood and room type. All right, so we are interested in these. We can count them individually by taking our data frame and passing a column name to the count function. So we could pass in neighborhood, for example, and run this, and it's going to give you the count for each of the values that is going to occur in these columns. For example, you can see here in the full data that we have these different names, these neighborhoods, and it's going to give you the counts of those here. And if we want to sort this, we could either use the arrange function, arrange by n, for example, or minus n if we want to arrange it top to bottom, descendingly, or we could just do the same thing here and just say sort equals true. And it's going to give you the same, a descending sort here on the count column. So we can see most listings are in Westminster. And we can use the same code for the second column that we're interested in, room type, and keep the sort true. And we can see it's mostly entire homes and apartments, and then private rooms, and virtually no shared rooms at all. Okay, so that is it for task 1. The next task that we're going to look at is task 2. Oh, no, one more. We have to print summary information on all numerical variables. And we're going to do the same thing, listings, and we can select our numerical values. Let's first look at the entire data frame, and we only want these double, 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 all of these that are numeric and might also be integers. Double are those with a dots, so floating point numbers, and integers would be something like 1 or 645 with no commas. We can use the select again, select where, and then instead of is character, we can say is numeric, and it's going to give us all of these different columns that are actually numeric, that are numbers. And let's see which ones we're interested in, which ones do we want to see summary information on. And we can select those by their names with the select statement as well. We are interested in the price, of course. We want to see what's the mean price, median price, maybe also minimum nights. Let's take this one as well. And reviews per month and calculated host listing counts. I don't know. Let's just take this as well. And we can see it gives us back these 4 columns that we've selected. Let's make it a little bit more pretty like this. And then we can pass it to the summary function, and it's going to give us summary information, minimum values, for example, maximum values, the mean and median, all of this. So we can see the mean price in London is 120 Great British pounds for 1 night, and the median is lower than the mean. That means that we have a right skewed distribution. That means that it has a long tail to the right, so outliers. And we can see the max value is 13K per night. So that is a nice Airbnb, I guess. Let's carry on with task 2. And Edward Tufte is often called the godfather of visualization, data visualization, and there is a Tufte principle as well. And you can look into this if you're interested. And one quote is, above all else, show the data. So we're going to do this in these 3 tasks. So the first thing that we have to do is calculate the median price for each neighborhood and plot it like this. So a bar plot, column plot, and sort it like this. So how do we do this? We have these different regions, these neighborhoods, and we have 1 median price value per neighborhood. So let's see how we can go about this. Task 2A. Insert a code chunk, take our listings data frame, and then see which variables we're interested in first. So we need the neighborhood and we need the price. What I like to do, even though it's not necessary, is take the columns that I'm interested in first and then think about how I can continue. So it's just less distracting than this huge output. So we have these 2 columns. What we want is 1 value per neighborhood. And you remember the count function? you can use the count, and you can see we have 33 different neighborhoods, and they occur that often. For one, we want basically a data frame like this, where we have the neighborhood and the median price next to it. And what we can do is take this. So we're going to start here, and then we can group by the neighborhood. That means every calculation that follows after this is applied to each group, each value within the variable that you give it. So it's going to apply the calculation to each neighborhood here in this column. And then we're going to summarize. And summarizing basically means collapsing many rows into fewer rows. So using many values for the same group to calculate one specific value. And you can, for example, say your new column that you want to calculate is median price. And what you want this to be is the function, so median of the price column. And in case you have missing values, it's good to say remove missing values. Otherwise, you're going to get an NA error. And if we do this, you can see our output, the data frame now has the 33 neighborhoods, and we have one median price for each of these different neighborhoods. So now we're going to use the ggplot, and we're going to pass the x and y column in the aesthetics function. So we're going to say on our x-axis, we want the median price, and on our y-axis, we want the neighborhoods. And then for ggplot, you can use pluses to layer different parts of the chart on top of each other. So you could say here, and you can run this, and what you get is your x-axis, your y-axis, but nothing on there. So now you can use the plus and put a layer on top. And we want a column, and basically that's what you do, geom col. And you can run this again. And there we go. Now we can see we've layered this column on top. Each neighborhood now has one column, but it's not quite what we want yet. Let's use the labs we can say the title will be median price by neighborhood, like this. And we want our y value to be nothing because we already said in the title it's the neighborhoods. We can just set it null, and the y axis label is going to disappear. And our y is median price. It's going to make it a little bit nicer, like this. Perfect. All right, so the next step would be to sort this, and we can use our pipe within the ggplot function as well. So we can say our neighborhood and pipe this into the factor reorder function, and we can say we want to reorder this by median price. And you can see it reordered the different levels within the character column by the median price. So it's now descending. And if we want to do it the other way around, you can just put a minus in front of that because it's a numeric value. And with the facet reorder, you can also specify the function that you want to use. You could default is median, I believe, or the actual value. And if you have multiple values for one group, you could use the mean function as well, or something else. But usually the default one is enough. Then if we want to specify a color, for example, midnight blue, that's the one I like to do for plots. Sorry, that's the color. You can see the mistake that I did was the color is the line around it, and we want to change the fill, not the color. Now we have this nice blue. And one last detail would be, for example, using a different theme. So the theme black and white would look like this, or the minimal would look like this. It's just, it changes the aesthetic of the diagram. Theme light is usually the one I like to go with. And one advanced trick is changing the x-axis, and we can use a continuous one because we have a numeric value on there. We can say our labels should be, and we can use a scales package, and this little double dots means from the scales package, pick this function. If you didn't use the library command before, you can just use this and write this, and then basically take any function from this package and say, please pick this and continue your business, basically. So we're going to use comma formats, And for thousands, it's just going to put a comma here. So it's easier to read. And in here, you can say suffix. That means after the number, put anything. So if we put anything, you can see it's going to appear behind the number. And because it's British pounds for London, we are just going to put Great British Pounds next to that. And that is task 2. For task 2A. For task 2B, we're going to jump back into our PDF, and it says count the room types for the 9 most frequent neighborhoods and normalize their frequency to a percentage and plot them into a bar chart. So that sounds pretty tough. It is a lot to do. So let's see how we can do this step by step. So we can see for the 9 neighborhoods. So our first step is to find the 9 most frequent neighborhoods. Find most frequent neighborhoods. The first step would be to count the neighborhoods. And we can see in our output here, it's not sorted yet. So we're going to slap this little sort equals true. You can also use a T as an abbreviation for true. And then on here, we're going to take the first 9 of these 33 neighborhoods. The head function can take the first 9. If we pass any number in here, it's gonna take the first X. We're gonna take the first 9. And then we're gonna pull a vector from this data frame, which is the neighborhood column. We're gonna pull the neighborhood vector. And now we have all of these neighborhoods that were in this column before. And we can save this in our most frequent neighborhoods variable like this. Okay, so if we look at this now, we can see it's stored in here. Okay, so the first step from here would be to filter only for the listings that are from these neighborhoods. So we can filter. That means throw out rows or just keep rows that adhere to some criterion. So we could say filter, and we want the neighborhood column to contain the values that are in, and you can use these percentage signs within as a trick, that are in our most frequent neighborhoods. And now we can see we get a data frame back that is a lot smaller than the one before. And it is because we only have the neighborhoods that we want. So that would be the first step. Next, we want to count our neighborhood, and we can see we have our 9 neighborhoods here, but we want the room type to be counted as well. And we can just pass 2 variables to here. So the 2 column names, put them in here, and now we get Camden, entire apartment, private room, shared room for Camden, then Hackney, entire room, private room, shared room for all of the 9 different neighborhoods. So we have 27 rows now. And now we can go ahead with the plotting. We can say aesthetics, specify X and Y axis. On the X, let's see what we did. We want the relative frequency. So actually we can't start plotting yet. You can see this is not relative, this is absolute. So within each neighborhood now, so within this, for example, we want to divide this value by all of these 3 values. So it's just a percentage. What percentage of Camden's room types is this, and this, and this? So we're going to use the group by again. Group by, nope, group by neighborhood. Because within each neighborhood, we want to change this column. And now we're not going to summarize because we want the same amount of columns out, rows out as before. We don't want to change the number of rows. So what we're going to do is mutate, which doesn't change the number of rows. You can just modify each row within the given column instead of collapsing them. So you can say n, the column that already exists. We want to divide each of these rows by the sum of all of the rows within each group. So we would sum these 3 values, 4K plus about 2K plus 85, and divide this by the sum, divide this by the sum, divide this by the sum. Then take the sum of this, and this, and divide this by the sum, divide this by the sum, divide this by the sum. So that's what we're doing here. And then if we enter, Alt-Enter to run this code chunk, or Control-Alt-C to run the entire chunk, we can see now it's normalized. We can see that this adds to 1, this adds to 1, this adds to 1, and so on. So now it is normalized, and we can ungroup to remove the group that exists here. You can see group is grouped by neighborhood. If we ungroup this, then we are good. And now we can plot. So on the x-axis, we want the frequency, the relative frequency here in percent. On y, we want the room type. Okay, and if you look at this, we can see it doesn't look quite the same as before. And the reason is that we want one of these plots for every neighborhood. And we can use the facet wrap function and the tilde, and we say we want this plot for every neighborhood. And now we can see it did exactly what we wanted. We have the neighborhoods here for every little plot and the x and y axis. And as a next step, we can add the column like before. And because we specified x and y already up here, we don't need to do this here anymore. And it fills in the columns. Wonderful. And if we look a little bit at this chart, it looks exactly the same. So we could do the same with labs, title, and everything, and change the theme and the percent, and everything is in the solutions. So I'm not going to go through that. You can figure that out by just experimenting with the solution code. So for C, let's plot the box plots by neighborhood of the price per night. So we can see in the chart, we have our neighborhood and then a box plot distribution here. So the good thing is box plots just take the entire data. So we can, we don't have to manipulate anything. We can just immediately start plotting. And we're gonna say on the x-axis, we want our price, and on the y-axis, we want our neighborhoods. And if you run this, we can see it looks a little bit like this. Price here, okay. And then we're gonna say geom box plots. And we can see it doesn't look at all like this. And the reason is we have outliers here. For Westminster, for example, there are AirBnBs that are more expensive than 10,000 Great British pounds. And that is quite expensive and is usually not a normal Airbnb that you want to live in for a couple of days. I don't know. Personally, I wouldn't do that. I don't know about you, but so let's just take them out. The thing is, if you change the scale, so you could say scale x continuous, and in here you could say limit and say which limit you want in a vector. We could say from 0 to 100, for example. The problem is now that it's gonna change the scale and remove values here. So that's not what we want to do. We want to keep the same scale and basically just zoom into the plot. And you can do this with coordinates Cartesian. And here you can say xlim for the limits. And we can specify in a vector which limits we want. And let's see here, I think we took 450, something like this. And now let's remove the color of the outliers as well. So outlier color is NA, no color for the outliers, and it looks better. Now we just want to sort the y-axis, and we can use the facet reorder again and reorder by price, and it's just going to take the median to reorder. And now we look very close to this, and we can say our labs, y is null, x is, for example, Great British pounds, and change the theme light. Okay, that's close enough. We can see it worked. Now we remove the outlier colors, zoomed into the chart, so we can see it better. I can show you what happens if we remove the outliers but don't zoom in. You can see The color is just removed, but the scale is the same. So we want to zoom in with coordinate cohesion. And there we go. Okay, so as the last task, we have a little model and we have a session on modeling as well. And we're gonna make you guys vote on which sessions we're gonna hold. So you can click on tidy models if you're interested in the modeling section. I'm not actually gonna go into the modeling here too deep because it is a big topic and I would have to explain a lot and that would make this video quite long. But if you're interested in this, I can really recommend you to watch Julia Silgi's YouTube videos. That's Julia Silgi. She explains in great detail how to use the tidy models package. And if we're going to do the session, you can join and we're probably going to hold it over Zoom. So everybody can join from everywhere. And we're looking forward to having you. If you have any additional questions for these solutions and think that this explanation wasn't detailed enough, you can just reach out to us on WhatsApp or on Instagram, and we'll make sure to make a video that explains the different concepts a little bit more and in an easier fashion. We hope you enjoyed this video and make sure to tune in the next time. Thank you.